In some previous videos, I've discussed the concept of beta in finance. Now, beta is a measure of systematic risk or non-diversifiable risk. And it's a measure of how volatile a stock's returns are relative to some market index. Okay, oftentimes we use the S&P 500. And what I want to do in this video is show you how you can actually compute beta using some real-world data. Now what I've done is I've gone to Yahoo Finance here, and after you look up a quote, you get this page. And if you look over on the left-hand side, you see something that says historical prices. And you can choose the dates you want. You can choose whether you want daily, weekly, or monthly data, or only dividends. And normally to compute beta, we use 5 years of monthly data. I'm only going to use 2 years here. And the reason I'm only going to use 2 years, there are two reasons. First, I tried it with 5 years, and I found that the scatter plot I'm going to show you was just too garbled. There were too many points. The second reason is that if I want to use kind of the most recent data, I'm going to get into 2009, 2010, when the market was extremely volatile. If you recall, we were just coming out of that, we were in the Great Recession where the stock market had tanked, and what we compute may not be reflective of how the beta actually is. So remember, beta is computed using a sample of data, so it's not a given. It'll change depending on which data we use. So I've chosen monthly data here, and I'm going to pick the dates. I'm going to pick December 31st of 2012, and I'm going to go to December 31st of 2014. And you say get prices, and you can see here that we have this information right here. Okay, all the dates and all the prices, and we have the date, the open price, the high price, the low price, the close price, the average volume, as well as the adjusted close price. And if we scroll down here, it tells us what the adjusted close price is. It's adjusted for dividends and splits. Now, I chose Berkshire Hathaway because there actually aren't any dividends. They've never paid a dividend under Warren Buffett's leadership, but they also have never split the stock. Now, part of the reason I wanted a stock that didn't pay dividends is that the way the information is given, the dividends will be sort of a separate line, and you'll have to manipulate your spreadsheet some in order to actually do the computation. So I wanted to make it as easy as possible. Now, if you have this information, you can download it to a spreadsheet by clicking this on, and depending on which browser you're using, I'm using Google Chrome, you can just click it on, and actually that's not the data I want. Oh, there's the data I want. So here's the data, and they give you exactly what was on the table. Now I'm not going to need the open, the high, low, close, or the volume, so I'm just going to delete those columns. Also, let's note that this is in reverse chronological order, so it's most recent to the earliest, and I really want it to be in chronological order. So here I'm going to go to data after I highlight the cells, and I'm going to click sort, and I'm going to sort A to Z. And now we have from December 31st until December 2014. So in order to get the return, so if I want the return here, I'm going to lose the first observation. That's the reason I picked December of 2012 rather than just starting at January of 2013. So the return is going to be the current price minus the previous year's price divided by the previous year's price, or the current price divided by, the current price minus the previous year's price divided by the previous year's price, or the current price divided by the previous year's price minus 1. So that's the formula I'm going to put in. So I'm going to say B3 divided by B2. So current price divided by previous price minus 1. And I hit enter and I get a return of around 8%. In fact, now let me just convert it to percentages. And in Excel, you can add a couple decimal places here. And I'll just copy the formula down. So now I have the returns for Berkshire, okay, between the end of December and the end of January, 8.81%, then 4.61, etc. Now you also want to do this for the S&P 500, but that's a little tedious for me to do all of these. I've already done this spreadsheet. So over here, I have this information. I've downloaded the S&P 500's prices, Berkshire's prices, and remember that the first Berkshire return was 8.81%, and I've computed the returns for the S&P 500. So the first thing I want to do is show you a little scatter plot. Okay, and we can just highlight this data. And we go to Insert, and this is a scatter diagram, and we don't want the points connected. So if we look here, let me move this over a little bit. Whoops. Let me move the whole thing over and make it a little bit larger. So if you look at this, we have the scatter diagram with the returns for the S&P down here and the returns for Berkshire on the y-axis. And what are we interested in? Well, beta measures the slope of this. And how do we get the slope? Well, you know, intuitively, what we're doing is we're basically trying to fit a line that best represents these points. And so there's an example. We've drawn this line through here, and that looks kind of reasonable. If I drew the line like this, you'd say, well, that's not really reflective of the relationship between the points. And if I drew the line like this, you'd say, again, that doesn't look right. But sort of halfway in between the points, okay, some of our actual observations will be above, some of our actual observations will be below. It'll kind of cut halfway through there. And what we're interested in, what beta is the slope of this line. That measures that volatility of Berkshire stock relative to the S&P 500. If it's greater than 1, then it's more volatile. That is, it goes up faster than the S&P, but it also goes down faster than the S&P. If it's below 1, then it's less volatile. So let's see what that slope is. Now there's some formulas maybe you learned in stats class, but let's just use the function that's in Excel. And the function is equals slope. It asks you for the known y's, and the y's would be the return on Berkshire, and that starts in E3 and goes to E26, and then you put a comma in, and then it wants the known x's, which start at F3 and go to F26, and if we click that, we get 0.93, so about 1, okay, a little bit less than 1. So Berkshire stock, at least during this time period, from 2013 through 2014, it went up and down roughly like the S&P 500. So if the S&P went up 1%, Berkshire went up around 1%. If the S&P went down 1%, Berkshire went down about 1%. Okay, so it's about the same level of volatility, and if we had computed the slope and all that, the slope would be right here where it crosses the x-axis. We could actually plot the real line. I'm not going to do that, but you can see that this is the way you calculate beta. You can actually look it up. If we go back to Yahoo Finance and we look at summaries, they actually have betas quoted here. Here it's actually 0.25, but this is a different time period over which they've estimated the data. So you don't usually have to do this yourself, but in the event that you need to calculate beta yourself, or you want to calculate it for a specific time period or use a specific index, this is how you can do it. Not too hard to do, very handy to do in Excel.